on transportation engineering and management. And myself, Abhilash BL, Assistant Professor, Department of Civil Engineering, Vidyavartaka College of Engineering, Mysuru. And I will be the MC for today's session. And I would like to introduce our today's speaker, Manoj P. He is Assistant Professor in the Department of Civil Engineering. From past 6 years, he is working as an Assistant Professor. And he studied BE in Civil Engineering from Vidya Vikasa College of Engineering, Mysuru, and MTech in Transportation Engineering from SIT Tumkuru. Currently, is pursuing his PhD from NIE College, Mysuru, based on the transportation engineering itself. Now, I would hand over the session to Manoj P. Sir.
Yeah. Good afternoon, everyone. It gives me an immense honor to be a part of this online training program on GATE 2021. I would like to thank our beloved head of the department, Dr. S.K. Prasad sir, and also the coordinators for providing this opportunity. Thank you. Today, I'll be discussing on the geometrical design aspects of rural highway, that is particularly on stopping side distance, overtaking side distance, horizontal curves, vertical curves. Okay, I will get back to the presentation. Okay. My topic is on transportation infrastructure and traffic engineering. This is the subject-wise weightage, which has been allotted for transportation infrastructure and traffic engineering. In the year 2018, payment from questions from payment materials, highway payments was 2, traffic engineering was 4, and transportation infrastructure was 2. That is total of 8. In the year 2017, we had for 9 marks. In the year 2016, we had for 6 marks. In the year 2015, we had for 9 marks. So the average total marks for this subject, transportation infrastructure and traffic engineering, is 7 marks. Especially on transportation infrastructure and traffic engineering, you'll be getting approximately 3 marks on an average. Now, we'll start with the topic, stopping distance. What do you mean by stopping distance? Stopping distance is a side distance. Sorry, side distance. Side distance is the actual distance along the road surface which a driver from a specified height above the carriageway will have visibility of the stationary or moving objects ahead of him. Or you can say that it is the length of the road visible to a driver at any instance. Okay, there are 5 types of side distance. First one is stopping side distance, overtaking side distance, intermediate side distance, headlight side distance, and side distance at intersection. Okay, stopping side distance, we can also call it as absolute minimum side distance. Intermediate side distance, when you cannot provide overtaking side distance, then you can provide intermediate side distance. This is nothing but twice the SSD. Headlight side distance is the distance visible to a driver during the night under the illumination of headlight. This is known as headlight side distance. Okay, side distance which is required to enter an intersection is known as side distance at intersection. Okay, this is the stopping side distance. Driver will be seated at a height, specified height, and the object will be at some height. Okay, normally for stopping side distance, driver height will be 1.5 meters and object height will be 0.15 meter. Okay, from this height, he should be able to see the object so that he applies the brake and stops the vehicle effectively without colliding. Okay, how do you analyze, how do you calculate the stopping side distance? Stopping side distance is the lag distance, a summation of lag distance plus braking distance. This lag distance is the time, is the distance traveled during the perception time. That is from the time he sights an object and the time till he apply the brake. That is lag distance. After application of brake also, the vehicle moves to some distance, that is known as braking distance. Then the equation used for calculating the stopping side distance is 0.278 capital V into T plus capital V square divided by 254 F. This capital V is nothing but the design speed in kilometer per hour. Here speed will be in kmph. Reaction time, it is if not given, then you have to assume the reaction time as 2.5 seconds as per IRC guidelines. F is the design longitudinal friction coefficient, and this is dependent on the speed of the vehicle. IRC has given this friction values for various speed or for different speed. When a gradient is introduced, if it is an ascending gradient, then it is plus. If it is a descending gradient, then it is negative, that is minus 254 F. If it is ascending gradient plus n, descending gradient minus n. Okay, these are all recommended longitudinal frictional coefficient for providing stopping side distance. Okay, this can be found from a code book as per IRC. Okay, for a speed of 60 kilometer per hour, longitudinal frictional coefficient as per IRC is 0.36, and for 65 kilometer per hour also it is 0.36. Normally in examination they may give you the speed of 60, 65 or 80. If they give you a speed of 80 kilometer per hour, then longitudinal friction F small f is equal to 0.35. What will be the recommended stopping side distance for different speeds? Yes, this is also given. Look, if in GATE exam, if you want to answer quickly without calculating, they have calculated and provided in the table for various speed. For 60 kmph, it is stopping side distance is 80. For 65 kmph, stopping side distance is 90. For 80 kmph, stopping side distance is 120. For 100 kmph vehicle speed, stopping side distance is 180. You need not calculate in exam. Directly, if they ask you if the vehicle is moving on a speed of 100 kilometer, what will be the stopping side distance, then you can directly write it is 180. If it is moving at 80 kmph, then directly you can write stopping side distance is equal to 120. And they may ask a question like this: what will be the stopping side distance for a two-way with single lane? Look, imagine you have only one lane, but two-way traffic is allowed. Then you have to provide twice the stopping side distance, because traffic will be moving in both the direction from one side to other side. Okay, so chances of collision is more. Whereas if you provide only one-way traffic, then if you have more than one lane or even one lane, then minimum SSD required will be equal to stopping side distance itself. So this you need to keep in mind. Next is overtaking side distance. What do you mean by overtaking side distance? Overtaking side distance is the minimum distance which is open to the vision of the driver of a vehicle intending to overtake the slow vehicle ahead with safety against the traffic of opposite direction. As you can look here, this is the overtaking operation. Okay, this is a slower moving truck. This is the faster moving vehicle. He will he'll be moving at a design speed, and what happens? He will follow this slower moving vehicle to some distance, and he will find a chance to overtake the vehicle and come back to its original lane. Okay, the overtaking operation should be such a way that here maroon color displays a faster moving vehicle, red color slow moving vehicle, whereas green is the vehicle coming from the opposite direction. Okay, maroon color vehicle will be traveling at design speed, and also green color vehicles will be traveling at design speed, whereas this red color vehicles will be traveling at slower speed. What happens is maroon color, he will be traveling at a design speed. As soon as he sees the vehicle, slower moving vehicle ahead of him, he will be traveling at the same speed, slower moving vehicle speed, and he finds an opportunity to overtake the vehicle at some overtaking zone or some well place, safe place. He should overtake in such a way that he should come to the next lane, overtake, and again come back to its original lane without colliding with the vehicle coming from the opposite direction. So overtaking side distance can be divided into three zones. Distance can be divided into three zones. That is, first distance is the distance traveled in design speed from this point to this point. Second distance is the distance traveled during overtaking operation, that is moving to the next lane and again coming back to its original lane. Whereas D3 represents this the distance traveled by the vehicle coming in the opposite direction. That is D3. So OSD is equal to D1 plus D2 plus D3. Okay, this is the equation, direct equation. OSD is equal to, if V is in kilometer per hour, then 0.28. The 0.28 is the conversion of kilometer per hour to meter per second. 0.28 VB into T. This is the reaction time T, small t reaction time, plus 0.28 into VB into capital T. Capital T is the time taken during overtaken. Time taken during overtaking operation. Plus 2S. S is nothing but spacing between the slower moving vehicle and faster moving vehicle. Plus 0.28 capital V into T. This spacing can be calculated using this equation, 0.2 into capital VB plus 6. Whereas the time taken during overtaking operation is dependent on the acceleration, and spacing. That is, T is equal to square root of 4 into 3.6 S divided by A. Here VB is equal to capital V minus 16. If not given, the speed of slow moving vehicle is the design speed minus 16. Maximum overtaking accelerations at different speed. This is also given by IRC for a design speed of 65. It is 3.28 kilometer per hour per second, and 0.92 for 65 kilometer per hour, 0.92 meter per second cube. That is overtaking acceleration. For a speed of 80, it is 2.56 kilometer per hour per second and 0.72 meter per second cube. Okay, overtaking side distance on a two-lane highway for different speed. Okay, here OSD is also calculated. This also, if they ask you in exam, if they ask you in GATE exam, you can directly say the OSD of vehicle traveling at 80 kilometer per hour, it is 470. Traveling at 65 kilometer per hour, it is 340. Traveling at 100 kilometer per hour, it is 640. This is also given here. Yeah, overtaking side distance, they may give you D1, D2. What will be the overtaking side distance for one-way road? Since D3 represents distance traveled by the opposite moving vehicle. For one-way road, you don't need the opposite vehicles. Okay, vehicles traveling in opposite direction, because there will be only one way. So for one-way road, it is D1 plus D2. For two-way road, it is D1 plus D2 plus D3. Here, intermediate side distance, as I already said, it is twice the stopping side distance. Yeah, headlight side distance is nothing but stopping side distance. That distance is equal to stopping side distance is equal to distance. Intermediate side distance, as I said, it is nothing but twice the overtaking side distance. Yeah, for 60 kilometer, your stopping side distance was 80, your ISD is 160. Here for 65, stopping side distance was 90, ISD is 180. For 80 kilometers, stopping side distance was 120. Now it is ISD is equal to 240. Criteria for measuring side distance. Yes, this you need to know. What will be the driver's height in case of finding a stopping side distance? Driver's height remains the same for all three conditions. whereas object height is just 0.15 for stopping sight distance, and for OSD and ISD, for both OSD and ISD, it will be 1.2 meters. So capital H will be equal to small h is equal to 1.2 meter for ISD. Capital H is equal to small h is equal to 1.2 meter for OSD. Okay, next is horizontal alignment. How will you get to know whether the alignment is the alignment in horizontal direction? Every time the questions arises, is it possible to always provide a horizontal, always provide straight roads? No, it is not possible. You need to provide curves. Okay, in order to provide curves, you need to provide super elevation, and also you need to provide extra widening at the curves. And whenever you introduce the curve, there should be a transition from straight to curve. And again, setback distance should be provided so as to provide a proper side distance in order to avoid collision. I'll discuss what is super elevation, why super elevation is provided. Okay, super elevation is provided so as to counteract the effect of centrifugal force and also to reduce the tendency of vehicle to overturn or skid. Okay, here the outer edge of the pavement is raised with respect to inner edge, thus providing a transverse slope throughout the length of horizontal curve. This transverse inclination is known as super elevation or cant or also banking. Here super elevation is denoted by small e. Super elevation is denoted by small e. It is the ratio of height of the outer edge with respect to horizontal width. The equation for calculating super elevation is equal to V square by GR, where E is the rate of super elevation, Ft is the transverse lateral friction coefficient. This is constant. Transverse lateral friction coefficient, it is equal to 0.15, whereas longitudinal friction coefficient, it differs. It varies. It is dependent on speed. V is the design speed value in meter per second. R is the radius of the horizontal curve. G is the acceleration due to gravity. This is also a constant, 9.8 meter per second square. Maximum super elevation. Why maximum super elevation? Why the super elevation should be limited? In order to avoid the danger of toppling of loaded vehicles, it may be slow moving vehicles, it is essential to limit the value of super elevation maximum. In case of plain and rolling terrain and in snowbound areas, maximum recommended super elevation is 7%. In hilly areas, it is 10. In urban road stretches with frequent intersection, it is 4%. Look, in exam, they may ask you questions like this. What is the maximum super elevation in a hilly road not bound by snow? Or they may ask you what is the maximum super elevation in a plain and rolling terrain in a snow bounding areas, then it is 7%. Or what is the maximum super elevation in urban road stretches? It is 4%. Okay, minimum super elevation is also there. Okay, from drainage consideration, it is necessary to provide some minimum cross slope in order to drain off the surface water. Okay, this table represents the recommended radii beyond which super elevation is not required. That is for a road with radius for a road with a radius 50 meter, assume a road with radius 15 meter for a design speed of 20 kilometer per hour, having a camber of 4%, then no need to provide super elevation. For a road of, for a road having a radius of 1100 and design speed is 100 kilometer per hour and the camber is 4%, then super elevation is not at all required. This table will recommend the radii beyond which super elevation is not required. Radius of horizontal curve. Radius, it is nothing but the ruling radius, minimum radius of a curve for the ruling design speed. R ruling is equal to v square by 127 e plus f. This is the equation in order to calculate the radius of the curve. Yeah, this is the equation. R ruling is equal to v square by 127 e plus f, where v is the speed in kilometer per hour, e is the super elevation, f is the uh, transverse friction. S is the transverse friction, not longitudinal. It is the lateral friction, that is 0.15 if not given. Yeah, widening of pavement on the horizontal curves, especially on a horizontal curves, when they are not of very large radii, it is common to widen the pavement slightly more than the normal width. You can have a look at this. Here, the road is widened, okay, more than the normal width. Why it is widened? Okay, mainly for two reasons. One is mechanical widening. The other one is psychological widening. Mechanical widening, it is the widening required to account for the off-tracking due to rigidity of wheelbase. It is called as mechanical widening. That is when this is something related to vehicle. This is something related to vehicle. So we are telling off-tracking due to rigidity of wheelbase. Psychological widening, this is something related to driver. Okay, extra width of the pavement is also provided for psychological reasons, so that he will be confident to curve, confident to turn the vehicle. Okay, such as to provide a greater maneuverability of steering at higher speed, and also to provide greater clearance for crossing and overtaking vehicles on the curve. The equations for mechanical widening is represented by Wm, and psychological widening is represented by Wps. So this extra width is the summation of both. Mechanical widening, NL square divided by 2R, where N is the number of N is the number of lanes, L is the length of the wheelbase, R is the radius of horizontal curve, and capital V is the design speed in kilometer per hour. Psychological widening, capital V divided by 9.5 square root of R. Using this equation, you can find the extra width. In GATE exam, they have asked question with respect to this. More questions have been asked with respect to extra width. They may ask separately, calculate the mechanical widening, and they may ask separately to calculate only the psychological widening. Okay, this is mechanical widening and this is psychological widening. We'll discuss numerical problems after this. What do you mean by a transition curve? You can have a look at this. Starting point of transition curve, ending point of transition curve, and here you have a straight line. You have a straight curve. Okay, transition curve on a non-circular, it is a non-circular curve. It is introduced between two straight curves. One is it is in between the two straight lines you have a curve. Okay, here the radius decreases from infinity. The radius will be infinity at the straight end, that is at both the tangent points it will be infinity, and then it will reduce to the desired radius of the circular curve. Okay, for gradual introduction of centrifugal force. Why this transition curve is provided? As I already said, it is provided so as to introduce gradually the centrifugal force, and also to enable the driver turn the steering gradually for his own comfort and security, and also to provide gradual introduction of super elevation as well as extra widening, and also to enhance the aesthetic appearance of the road. This transition curve is provided. What is the length of transition curve? How do you calculate the length of transition curve? By rate of change of centrifugal acceleration. You have three cases by which you can calculate the length of transition curve. By rate of change of centrifugal acceleration, L S1 is equal to Q by C into R, where C is the centrifugal acceleration. C can be calculated using this equation, 80 divided by 75 plus V. V is the design speed in kilometer per hour. So Ls is equal to V cube by CR by rate of introduction of super elevation, that is transition curve, second case. This is nothing but W plus WE. W is the width of existing road. W is the extra width provided. WE is the extra width provided, and this E represents super elevation multiplied by number of lanes. Sorry, multiplied by gradient. By empirical formula method for plain and rolling terrain, it is 2.7 V square divided by R. For steep and hilly terrain, it is V square divided by capital R. You have three cases. You will calculate LS1 from when you know the value of when you know the value of C, you'll calculate LS1, and by rate of introduction of super elevation, you calculate LS2, and if it is a plain and rolling terrain, you will calculate LS3 using this equation or using this equation. The maximum out of the three cases, maximum value out of the three cases is considered as the length of transition curve. Next comes the setback distance. Setback distance, it is the distance from the center of the horizontal curve to an obstruction on the inner side of the curve. You can have a look at this. This is the road. This is the road, 7-meter road. This is the center line of the horizontal curve or center line of the road. Okay, this is the inner side of the curve. This is the inner side of the curve. Distance from horizontal curve to the inner side of the curve, where there is an obstruction. Okay, where there is an obstruction is known as setback distance. Here, M represents setback distance. This curve is having a radius of R. This curve is having a radius R. And what is the angle of the curve? Angle of the curve will be alpha. Angle of the curve will be alpha. This portion is alpha by 2. That is half of the curve is alpha by 2. Okay. From here, from this point to this point, it is R. Whereas inside, I mean, from the point to the obstruction, it is R cos alpha by 2. R, this radius multiplied by cos alpha by 2. Yeah. We'll analyze the setback distance. When the length of the curve is greater than stopping distance, this is for a single lane road. That is length of the curve is greater than stopping distance or side distance, stopping side distance. Then what will be the arc length? Okay, this arc length will be common for everything. What will be the arc length? Arc length is denoted by R multiplied by the angle alpha. r multiplied by the angle alpha, that is arc length. S is equal to r multiplied by alpha. Alpha is equal to s by r minus radius. Yes, this can be found out. Alpha by 2 is equal to s divided by 2r. Alpha by 2 is equal to s divided by 2r. And also, if you, this is in radians, this is in radians. If you want this alpha by 2 in terms in degree, then it is 180 into s divided by 2 pi. This is a conversion how in order to have alpha by 2 in terms of degree. Okay, we'll analyze the same. When the length of the curve is greater than stopping side distance, you have a curve here. You have a curve here. Okay, I think okay, this is not the image for this. This we'll have a look at this image only. When the length of the curve is greater than length, this is the length of the curve. This is the length of the curve. It is greater than the stopping side distance. This is greater than the stopping side distance, where m is equal to c to f. From here, this point to this point, this is the setback distance. Okay, how do you calculate this CF? It is OF minus OC. Okay, M is equal to OF minus OC, that is equal to this OC, sorry, this is OC minus OF. OC is equal to R. OC is equal to R. OF will be r cos alpha by 2, as I already discussed here. This will be r cos alpha by 2. So the setback distance when length is greater than s is r minus r cos alpha by 2. So alpha by 2 will be, if you want to convert this into radians, only this alpha by 2, it is 180 s divided by 2 pi r. Okay, this is in case of single lane road when L is greater than S. In case of L greater than S for a multi-lane road. I'm talking about multi-lane road, that is if it is a 2-lane or more than 2-lane. Okay, this is the center line of the road. This point represents the center line of the road. Setback distance is denoted by m dash. Setback is denoted by m dash. Okay, from the center line till here you have m, and from the center line of the road to the inner circle, inner line of the to the border of the inner curve, that is that distance is d. D is the distance between center line of the road and center line of the inside lane, that is in a curve. This point, only this point is d. So this r minus this point, that is r minus d. So this r minus this value into cos alpha by 2, you will get the setback distance m dash. Okay, the r minus d ಎಲ್ಲಿಗೆ ಬರುತ್ತೆ? This r minus d cos alpha. Okay, only this value. Look here, from here to here, I'm talking about from here to this point, that is equal to r minus d cos alpha. So what will be the setback distance? M dash. M dash will be equal to r minus d cos alpha by 2. You will get m dash. Alpha by 2 is equal to 180 s divided by 2 pi r minus d. Okay, this is another case when length is less than yes. When length is less than yes. you can have a look at this. The length of the curve is less than the side distance. Length of the curve is less than the side distance. You have this extra space denoted by x. Here also you will be having this extra space denoted by x. X is equal to, this x value will be equal to s minus the side distance minus length of the curve divided by 2. Okay, this value, x value, extra value will be equal to s minus length of the curve divided by 2. Since here it is forming a triangle, in horizontal direction. Okay, so the angle will be sine alpha by 2. This angle will be sine alpha by 2. Okay, what will be the setback distance? What will be the setback distance here? Setback distance is equal to FC from this point to this point, that is the setback distance, that is FG plus GC. This GC, what is this GC value? GC value, as I already said, it will be R from this point to this point, R minus R cos alpha by 2 minus R cos alpha by 2. So you will get the value of GC as R minus R cos alpha by 2, whereas FG, this point extra, FG will be S, when S is nothing but side distance, S minus LC by 2, the angle will be sine alpha by 2. So M dash, that is the setback distance, will be equal to R minus R cos alpha by 2 plus S minus LC by 2 into sine alpha by 2. Okay, that was in case of single lane road, whereas in case of multi-lane road, as I already said, this extra D portion will be there. So instead of R cos alpha by 2, R minus D cos alpha by 2. Only this part is changed. You need to know this final equation. When the length of the curve is less than S, M dash is equal to R minus D cos alpha by 2 plus S minus LC by 2 into sine alpha by 2. This is the setback distance when L is less than S. This is something with respect to setback distance. Now moving to vertical alignment. Okay, vertical alignment is nothing but the elevation or profile of the center line of the road. Here under vertical alignment, you will have gradient, summit curve, and valley curve. A gradient, it is nothing but the rate of rise or fall along the length of the road with respect to horizontal. It is known as gradient. Gradient can be expressed in terms of 1 in x, or that is nothing but 1 vertical to 1 horizontal, or also you can express gradient in terms of percentage. Okay, you have, as per IRC, for different types of terrain, different ruling gradients, limiting gradients, and exceptional gradients are provided. Now, what do you mean by ruling gradient? What do you mean by limiting gradient, and what do you mean by exceptional gradient? Ruling gradient, it is the maximum gradient which the designer will attempt to design the vertical profile. Limiting gradient, it is steeper than ruling gradient. In hilly areas, it may frequently be necessary. Whereas exceptional gradient, it is even more steeper than this limiting gradient, and it has to be provided only at unavoidable situations. The stretch of this exceptional gradient should be less than 100 meters. And other than this, one more thing is there, minimum gradient. As minimum gradient is provided for drainage purpose, and it depends upon rainfall, type of soil, and other conditions. Okay, In exam they may ask you what is the limiting gradient, like this, what is the limiting gradient for a plane and rolling terrain. They may ask, give option as 4, 5, 6 and 7%. The answer is 5%. And for mountainous terrain and steep terrain having elevation more than 3000 meters above mean sea level, limiting gradient is 6%. For a steep terrain up to 3000-meter height above mean sea level, the limiting gradient is 7%. This you need to know. What will be the limiting gradient for mountainous terrain? For a rolling gradient, 5%. Exceptional gradient for a mountainous terrain is 7%. Likewise, steep terrain for in exceptional gradient is 8%, limiting gradient 7, rolling gradient 6%. Okay, this is all recommended by Indian Road Congress or IRC. Yeah, vertical curves. The under vertical curves, due to change in the gradient in the vertical element of highway, it is necessary to introduce either summit curve or valley curve at the intersections of two different grade. You can have a look at this. This is having the crest upward. Okay, this is a summit curve with convexivity upward. The curve having a convexivity upward is known as the summit curve. The length of the summit curve is guided by the side distance consideration. When L is okay, here you have two cases. That is when the length of the summit curve is greater than or equal to stopping side distance, and when L is less than stopping side distance. You can directly refer to this formula. Okay, when L is greater than stopping side distance, L is equal to n square divided by square root of 2h plus square root of 2 small h the whole square. Or here the square root of 2 capital H plus square root of 2 small h the whole square. Directly you can say that for if this S is SSD, you can say this value is 4.4. If this S is OSD or ISD, then it is 9.6. How you got this value? You have substituted the value of H as 1.2 and 0.15 for SSD and 1.2 for capital H and small h for OSD. When you substitute and equate, you will get this denominator as 4.4 in case of SSD and 9.6 meters in case of ISD or OSD. Okay, likewise here also 2s minus 4.4 in case of SSD, 9.6 in case of ISD or OSD, the whole square divided by n. So you will be knowing the value of S. N is nothing but deviation angle. That is the algebraic difference in the gradients. And the small h is the height of this object. Capital H is the height of the high level above the roadway surface. Valley curve. Yeah, this is a convexivity downwards or concavity. Okay, this is here valley curve can be found out using two equation. One is from comfort condition, the other one is headlight side distance criteria. Okay, valley curve length of valley curve from comfort condition L is equal to 2 square root of NV cube divided by C. Okay, in case of headlight side distance, when you have two cases, one is when L is greater than stopping side distance, and the other one is when L is less than stopping side distance. Okay, when L is greater than or equal to stopping side distance, it is equal to n square divided by 2h1 plus 2 into s tan alpha. This alpha will be equal to 1%. Keep in mind, this alpha will be equal to, sorry, 1 degree, not percentage, 1 degree. This alpha will be equal to 1 degree. S is either S is headlight side distance, that is not nothing but stopping side distance. H1 height of the headlight above the road surface, height of the headlight above the road surface, tan alpha is 1 degree. Yeah. Whereas H1 it is 0.75 meter. When you substitute the values here, you can get direct value, that is 1.5 plus 0.035. Yes. If they ask you question with respect to this, I want you to substitute directly. N square divided by 1.5 plus 0.035 into yes. This C is constant. Yeah, minimum length of vertical curve. What should be the minimum length of vertical curve? This is also given by IRC for various design speed. Let us say for a design speed of 80, the minimum length of vertical curve should be 50 meters. For a design speed of 100 km per hour, minimum length is 60. For design speed of 50, minimum length should be 30 meter. This is the IRC recommended minimum length of vertical curves. Lateral and vertical clearances. What should be the lateral clearance and what should be the vertical clearance? Lateral clearance is towards your side. Okay, distance between the extreme edge of the carriageway to the nearest face of the structure. Okay, normally it should be equal to shoulder width. Normally it should be equal to shoulder width. That much lateral clearance should be provided. Whereas vertical clearances, okay, from this road surface to the top surface of this, height above the highest point of the traveled way to the highest point of the traveled way to the lowest point of the overhead structure. This is the traveled way, that is the carriageway, highest point to the lowest point of the overhead structure. It should be minimum 5 meters. Okay, it should be minimum 5 meters. Now we will discuss on the questions. We'll solve the questions. First, I would like to solve 2 marks question on all the concepts which I explained. That is, we'll be solving on stopping side distance, extra width, radius, vertical curves. Okay, we'll analyze. First question, a horizontal circular curve is provided with a center line of radius 200 meters, is provided on a two-lane, two-way state highway section. The width of the two-lane road of 7 meters. Design speed of this section is 80 km per hour. Brake reaction time is 2.4 seconds. Coefficient of friction in longitudinal and lateral direction is 0.355 and 0.15 respectively. What is the stopping side distance on a section? Look here, in exam, they will give you unwanted values. We don't need this radius value. We don't need how much lane it is. We don't need the width. What we need is only the speed, 80 km per hour, and time, reaction time 2.4 seconds, and we need the longitudinal friction 0.355. The stopping side distance on a section is, the options given are 221, 195, 125 and 65. This should be in meters. This should be in meters. How do you calculate this? Okay, you know that stopping side distance is equal to lag distance plus braking distance. Okay, 0.278 into your V value is 80 kilometer per hour. V value is 80 kilometer per hour. V value is 80 kilometer per hour and T value is 2.4 seconds. Okay. Substitute the values here. Substitute the values here. You will get substitute the values here, you will get the answer as 125 meters. So for this question, 80 kilometer is the speed, 2.4 is the reaction time, and longitudinal friction F is equal to 0.355 or 0.36. So stopping side distance will be equal to 125 meters. Substituting the values in this equation, you will get 125 meters. Okay, we'll go to next question. A horizontal curve with the center line of radius 200 meter. Sorry, we go to the next question. The radius of the horizontal circular curve on a highway is 120 meter. This is also not required. The design speed is 60 km per hour, and the design coefficient of lateral friction between the tire and road surface is 0.15. Okay, F value is given, estimated value of super elevation required. What is this E value? Okay, if full lateral friction is assumed to develop, that is when F is equal to 0.15. That is one case, and the value of coefficient of friction needed if no super elevation is provided will respectively be. The option given is 1 divided by 11.6 and 0.1, 1 divided by 10.5 and 0.37, 1 divided by 11.6 and 0.24, 1 divided by 12.9 and 0.24. Okay, how do you calculate this? Okay, they have asked you to calculate the super elevation E. They ask you to calculate the super elevation E and also to calculate the coefficient of friction needed. What is the equation in order to calculate super elevation? E plus F is equal to V square by G into R. What is the value of E? What is the value of E? Substitute V square divided by G into R. The value of value of V is 0.278. Value of E is 0.278 into 60. This value will get 16.67. 16.67 the whole square divided by G is 9.81 into R. The value of R given in the question is 120 meters. Value of R given in the question is 120 meter. F value given in the question is 0.15. Substitute the values, you will get the value of E is equal to 0.086. That is 1 divided by 9.6 value of E. Whereas the value of F, they have asked you to calculate value of F if no super elevation is provided. That is when the value of E is 0. When the value of E is 0, F value is equal to V square divided by G into R. Directly calculating F is equal to V square by G into R. So F V is 60 kilometer per hour. This you need to convert in terms of meter per second. That is 0.28 into 60 divided by G is 9.81 into R is R is 120. You will get 0.24. to be precise, you will get F value is equal to 0.236. So the answer is 1 divided by 11.6 and 0.24. Okay, next question. A road is being designed for a speed of 110 km per hour or a horizontal curve with a super elevation of 8%. If the coefficient of side friction is 0.1, the minimum radius of the curve required for safe vehicular movement is. Options are 115, 152.3, 264.3 and 528.5. How do you calculate this? What they asked you to calculate the minimum radius of the curve. Minimum radius of the curve, equation for calculating this when super elevation is given, same equation, that is E plus F is equal to V square by 127 R, or directly you can put this equation, that is V square divided by 127 into E plus F. E value is given in question as 8%. F value is coefficient of friction, F is 0.1, E is 8%, so 0.08. Substitute the values. V is 110 kilometer per hour. Substitute the values, you will get the ruling radius as 528.5 meter. This is in terms of meter. Okay. Next question. The design speed of a two-lane road is 80 km per hour. When a design vehicle with wheelbase of 6.6 meter is negotiating a horizontal curve on the road, the off tracking is measured as 0.096 meter. The required widening of carriageway on a two-lane road on a curve is approximately. The options are 0.55, 0.65 and 0.75 and 0.85. Okay. How do you calculate? You have the equation for widening, extra width, that is mechanical widening plus psychological widening. Okay. Equation is NL square divided by 2R plus V divided by 9.5 square root of R, where N is the number of traffic lane, L is the length of wheelbase, R is radius, V is the design speed. What is asked in the question? What is asked in the question? I mean, what is given? Given value is speed 80 km per hour, design wheelbase 6.6 meter, and off tracking measured is 0.96. 0.096. Okay, the required widening on a carriageway on a road is approximately how much? This can be calculated using the equation. This can be calculated using this equation, where n is equal to number of lanes. It is a two-lane road. L is equal to length of wheelbase 6.6 is given, and R is given radius of horizontal curve. R is not given. We need to calculate R, but this half tracking off tracking is given, that is this L square divided by NL square divided by 2R is equal to 0.96. From this equation you will get R. R is equal to 226.8. R value is equal to 226.8. Substitute the R value in this equation, that is for a speed of 80 kilometer, for a speed of 80 kilometer, 80 divided by 9.5 square root of R. 80 divided by 9.5 square root of R. Substitute here, you will get the answer as 0.75 meter. Next question. It is also similar equation should be used, but question they have asked is different. A two-lane one-way road, a two-lane one-way road with a radius of 50 meter. What is the radius? 50 meter. What is the wheelbase? 5 meter wheelbase. Okay, the speed of lorry is restricted between 60 kilometer to 80 kilometer per hour. That is, you have two speeds. One is 60 kmph, the other one is 80 kmph. Okay, are designated as width of mechanical designated as mechanical widening as a WME. This 60 represents the speed, 60 kmph. PS represents psychological widening. The mechanical widening and psychological widening required are 80 required at 80 kmph are designated as same WME 80 and WPS 80 respectively. Now they asked you the correct values of mechanical widening as well as psychological widening for both 60 kmph and 80 kmph. Look here, the answer is simple. Using the same equation you're supposed to do, but the question they ask you is quite different. They have asked you here is separately what is mechanical widening and what is psychological widening. Okay, this is this first two value represents mechanical widening and as well as psychological widening for 60 kmph. Last two represents for 80 kmph. Okay, these are the options given, but solution, yes, you know the equation for mechanical widening NL square by 2R. You know the equation for psychological widening, that is V divided by 9.5 square root of R. Okay, V divided by 9.5 square root of R. First question, what they have asked, WME, that is mechanical widening for a speed of 60 kmph. You know it is a two-lane road and the length of, this wheelbase is 5. So 2 into 5 square divided by 2 into radius is given as 50. Radius given as 50 meter. Okay. So 2 into 5 square divided by 2 into 50. This is for 60 kilometer speed as well as for 80 kilometer speed. Okay. Next is they have asked you for 60 kilometer speed, what is the psychological widening? That is here V is 60 divided by 9.5 square root of 50. This value you will get 0.89. This value for 60 kmph it is 0.5. This value for that is PS psychological width for 60 kilometer per hour it is 0.89. Again, mechanical widening for 80 kilometer per hour. Look, this is not dependent on speed, so it is 0.5. Mechanical widening for psychological widening for 80 kilometer per hour it is 1.19. When you substitute, that is 80 divided by 9.5 square root of R, you will get 1.19. 0.19. So the answer is B. Correct answer is B. For this question, this was asked in GATE 2019 paper 1. Okay. The extra next question, the extra widening required for two-lane national highway at a horizontal curve of 300-meter radius, considering a wheelbase of 8 meter and a design speed of 100 kilometer per hour, is how much? Look, they have given you the option as 0.42, 0.62, 0.82 and 0.92. Solution is same equation. Same equation can be used. Okay, they have given the radius r and speed v is equal to 100 and wheelbase L is equal to 8. So L is equal to 8. N is the number of lanes, 2 lane, 2 into 8 square divided by 2 into R is given as 300. Substitute the values, 100 kilometer speed, 100 divided by 9.5 square root of R given as 300. So the answer you will get as 0.82. That is 2 into 8 square divided by 2 into 300 plus 100 divided by 9.5 square root of 300. You will get 0.82. Okay, this is something with respect to extra width, extra widening required. Next. What is the minimum length of the transition curve for a design speed of 80 kmph in a horizontal curve of 240 meter radius? Okay, now we are talking about transition curve. The solution for this is, as I already discussed, maximum of LS1, LS2 and LS3. But here super elevation is not given in this question. Super elevation E value is not given in this question. You need not worry about that. Directly by rate of change of centrifugal acceleration, LS1, this will be equal to LS1 is equal to 0.0215 V cube divided by CR, where C is equal to 0.516. If you substitute the value of V here, you will get 0.516 meter per second cube. What is the value of V? V is 80 kilometer per hour. It is 80 divided by 75 plus 80. You will get this value. LS1 is the equation for this is 0.0215 V cube divided by C into R. You will get some value here. By empirical formula for plane and rolling terrain, here they have not given what type of terrain condition it is. So you need to do for both plane and rolling terrain as well as for steep and hilly terrain. So the value will be maximum of L1, L2 and L3. Here the answer is 72 meters. The answer is 72 meters. That is something with respect to transition curve. Next is something with respect to setback distance. What is given in setback distance? Here a two-lane highway, horizontal curve of 200 meters. Total length of the curve is 240 meters. Distance between central lane of highway and center of inner lane is 1.95. Here side distance is also given. If the side distance is 340, what will be the setback distance. Side distance S is 340, length of the curve is 240. What is the condition? Length is less than, yes, L is less than, yes. This is a multi-lane road. As I already said, it is a 2-lane road, so it comes under multi-lane category. Equation for calculating setback distance is R minus D cos alpha by 2 plus S minus LC by 2 into sin alpha by 2. Okay, alpha by 2 you need to calculate first. This alpha by 2 because you are converting it in terms of degree. It is 180 s divided by 2 pi r minus d. That is, when you substitute the values here, you'll get 34.7 degree. You'll get 34.7 degree. And what is the value of d? What is the value of d here is 1.95. That is the distance from the center lane and center of the inner lane. That is 1.95. R value is 200. That is 200 minus 1.95 cos 34.7 degree plus plus 340 plus 340 minus 240 divided by 2 into sine 34.7 degree. When you substitute the values here in this equation, you will get the setback distance as 66 meter. So the answer for this is 66 meter. Okay. Next, the horizontal curve. Okay, this is also another form of asking question with respect to setback distance. Horizontal circular curve with a center lane radius is of 200 meter is provided on a two-way state highway. Width of two-lane road is 7 meter. Some unwanted values will be there in your question, but you need to take only the wanted values, only the important values required for solving the question. Okay, the width of two-lane road of 7 meters, design speed of 80 of this section is 80 kilometer per hour, brake reaction time small t is equal to 2.4, coefficient 0.355 and 0.15 respectively. They ask you to find out the setback distance from the center line of the inner lane. Options given are 7.93, 8.1, 9.6, 9.77. Please go through the question once again. They have not given the stopping side distance. They have not given the value of s. Here what you are supposed to do, you have to first calculate the value of s. Now to calculate the value of s, you need the value of v. V given here is 80 kilometer per hour, and t instead of 2.5 brake reaction time they are given 2.4. 80 square divided by f. Yeah, with respect to this f, you need longitudinal friction only. It is dependent on speed, or it is, if it is given longitudinal friction 0.355. Okay, substitute the values, you'll get s value. After you get s value, you need to calculate alpha by 2 value. Alpha by 2 value is equal to 180 s divided by 2 pi r minus d. 2 pi r minus d cos alpha. Look here, using this equation, substitute the values, and then d is the distance between center line of the road and center line of the inner side. Okay, substitute the values in this alpha by 2. First you need to calculate r minus d cos alpha by 2. You get 8.1 meter. So here the unwanted value is 0.15. two lane 7 meters, this two lane two way. Okay, horizontal curve of radius, I think, yeah, radius is required, but two lane two way is not required. Two lane 7 meters, I think it is also not required. Yes, but yeah, two lane road is required because you have to choose whether it is a single lane or multi lane road. The answer is 8.1 meter as discussed previously. Next is with respect to valley curve. A crest vertical curve joins two gradients plus 3 and minus 2. Okay, that is it will move up and come back. For a design speed of 80 kmph and a corresponding stopping side distance of 120, SSD given here is 120, height of driver's eye and object above the road surface are 1.2 meters and 0.15 respectively. They are given H value, capital H and small h, curve length, which is less than stopping side distance. They have given the condition also, that is L is less than SSD. Options are 120, 152, 163 and 240. Okay, we know that this is a summit curve and L is less than. Yes, the equation can be directly put here. You substitute the values here, 2s minus square root of 2h plus square root of 2h the whole square divided by n. Substitute the values given there here. You will get the answer as 152. In order to find out this n value, deviation angle, that is plus 2%, plus 3%, that is 3 divided by 100, minus of minus 2%, that is 0.03 plus 0.02, you will get 0.05. This n value will get 0.05. 2 into 120 minus square root of 2 into h value is 1.2 plus square root of 2 into 0.15, this whole square divided by n value is 0.05. Substitute, you'll get L value is equal to 152 meters. So correct answer is 152 meters. Last question, they have not given options for this to calculate the direct answer. Without option, you need to write. This is 2 marks 2013 gate paper. Okay, for a portion of national highway where a descending gradient of 1 in 25 meets an ascending gradient of 1 in 20. This is a valley curve. It needs to be designed for a speed of 90 km/h based on the following condition. What they given is headlight side distance is equal to stopping side distance. We know that of a level terrain considering the length of the valley curve greater than L greater than SSD. What they are given is L greater than SSD. Next is they are given allowable rate of change of centrifugal acceleration as 0.5 meter per second cube. Assume reaction time small t 2.5 seconds, coefficient of longitudinal friction small f 0.35, height of headlight small h 0.75 and alpha as 1 meter. What is the length of valley curve based on comfort condition? This is very simple. For a comfort condition, valley curve is L is equal to 2 square root of NV cube divided by C. For headlight condition, L is equal to, you have two cases. One is when L is length is greater than SSD and the other one is length is smaller than SSD. Here, in this case, length is greater than SSD. So you are going to use this equation, substitute, and you will get the value of L. You will get the value of L when you substitute this equation. I think the answer will be between 106 to 107. Answer will be between 106 to 107. Okay, this is the solution for Rayleigh curve. I think I have covered stopping side distance, how to calculate the radius, and in case of super elevation, extra widening, vertical curve, setback distance. With respect to that, you will have numerical problems for 2 marks. Here, for 1 marks question, I'll go quickly. Recommended longitudinal friction coefficient for providing stopping side distance for a speed of 60 kmph. I have shown you the table. Based on the table, the speed of for 60 kmph, it is 0.36. Height and object's height for measuring SSD. For measuring SSD, it is 1.2 and 0.15. Recommended maximum limit of super elevation for plane and rolling terrain in a snowbound area. Okay, this is plane and rolling terrain. It is 7 meter for plane and rolling terrain. What will be the rolling minimum radius of the curve for a rolling design speed? V kilometer per hour. Okay, you have R rolling, radius, rolling radius. It is V square divided by 127 E plus F. V square divided by 127 E plus F. The formula for calculating mechanical widening, NL square divided by R. NL square divided by R. Look, they may ask you this for 1 marks. Limiting gradient for plane and rolling terrain. It is limiting gradient for plane and rolling terrain. It is 7%. This is not highlighted here. It is 7%. Height of headlight above the road surface is 0.95 meter. Angle of inclination of headlight beam with horizontal alpha, that is alpha is equal to is 1%. Minimum length of vertical curve for 100 km speed is 60 meter. This is from the table. Minimum vertical clearances as per IRC. Vertical clearance. This was shown. It is 5. This is 5 meter. Reaction time of driver as per IRC guidelines. It is 2.5 seconds. It is 2.5 seconds. Thank you. Yeah, I think if you have asked the questions, what does that what does that PP indicates? PP underscore 15 indicates. Look, that is the page number from your IRC code, IRC 73 1980. You can go refer IRC 73 1980. That is the geometrical design standards for rural highways code book, IRC code book for geometrical design standards for rural highway, that is a non-urban highway. And someone has asked, isn't OC minus OF as OC is equal to R? Yes, that is correct. But here in the diagram, it was wrong. Yeah, OC is R, R minus D. OF will be below that. That is correct. In case of gradient, ruling gradient is smaller than limiting gradient, is smaller than exceptional gradient, is smaller than minimum gradient. What they have asked is in the opposite direction. Ruling gradient will be more, then limiting gradient will be provided. Limiting gradient should be provided. At some places, exceptional gradient will be provided. and then maximum gradient is provided. Wait a second, with respect to gradient, I'll tell you on. Wait a second. Yeah, with respect to gradient, exceptional gradient is more than limiting gradient, yes. Limiting gradient is more than ruling gradient, yes. But minimum gradient after minimum gradient is not greater than the exceptional gradient. Minimum gradient is the least. After minimum gradient comes the ruling gradient, and after that limiting gradient, and after that exceptional gradient. Yeah, and why are we not using E plus F is equal to V square by GR? For simplification, what I did was I put the R in left hand side, E plus F in the right hand side, that is in the denominator. So R is equal to V square divided by G into E plus F. Directly you will get radius. Using this equation, E plus F is equal to V square by GR. R is equal to V square by G into E plus F. Directly you can get the radius. In question number 9, okay, question number 9, length of the curve is not, length of the curve is given. Horizontal curve with a center line, radius. Okay, this is radius, width, speed. Fine. If the length of the curve is not given, what we will assume is, we'll assume that the length of the curve is less than stopping side distance. Okay, normally they will give, what we have done here is we have assumed the case as L is less than the stopping side distance. That is, stopping side distance will be more. If the stopping side distance is more, then safety will be more. So as per the assumption that stopping side distance is more than the length of the curve, we will calculate the setback distance. Okay. Yeah, I'll be sharing the PPT after this session. If you have any doubts, you can ask me anytime. Tomorrow afternoon also my session will be there. So if you have any doubts with respect to this PPT, these slides, you can ask me tomorrow also. Thank you.
Yes. Thank you, Manoj sir, for an informative session. Thanks for the patient listening for all dear participants. Yes, we will be back tomorrow at the same timings for the day 3 session on the same topic, that is transportation infrastructure and traffic engineering by Manoj P and structural analysis by Professor Kanmani SS. Thank you. Thank you all.